Solve the following inequation. Write down the solution set and represent it on the real number line. So what we have is minus 2 plus 10x less than or equal to 13x plus 10 less than 24 plus 10x, and x belongs to z. Z, remember, is integer. So our integers is our replacement set. This question was asked way back in the ICSE 2018 exam. Now again, if you remember, if we have this double inequality, we need to break them apart and solve them in two parts. So first part will be this, which is minus 2 plus 10x less than or equal to 13x plus 10. That's our first part. And a second part is going to be here, which is 13x plus 10 less than 24 plus 10x. So we're going to solve these two inequations separately and then combine our final answer, right? So for solving the first part now, minus 2 plus 10x, so the first thing would always be to rearrange the terms. So let's take the plus 10x from the left hand side to the right hand side, the plus 10 from the right to the left. So that gives us minus 2 plus 10 becomes minus 10 is less than or equal to 13x minus 10x, right? Further, minus 2 minus 10 makes it minus 12, less than or equal to 13 minus 10 makes it 3x. The 3 plus 3, the 3 on this side, multiplication, to the other side becomes division, so it is minus 12 upon 3 less than or equal to x. So this gets cancelled out. Minus 12 upon 3 will give me minus 4 less than or equal to x. Alright, so that's the first part of the inequation. The second part now, if I have to solve that, again the first step would be rearranging the terms, bring the x terms together. So the plus 10x on the left hand side, bring it to the right, sorry, from the right hand side bring it to the left, the plus 10 from the left, take it to the right. What I end up with is 13x, the plus 10 becomes minus 10x less than 24, and the plus 10 here becomes minus 10 on the left, on the right, sorry. 13x minus 10x makes it 3x less than 24 minus 10 is 14. Now 3x on this side, the 3 taken from multiplication to the other side becomes division. So I get x is less than 14 upon 3. This doesn't get cancelled perfectly. So I can convert this improper fraction to a mixed fraction. So 14 upon 3, 13 4s are 12. So 4 and 2 is the remainder. So 4, 2 upon 3. So x is less than 4, 2 upon 3. Alright. So that's what we get after solving both our parts. Now if I had to write them down, I can say therefore minus 4 is less than or equal to x, which is less than 4, 2 upon 3, and x belongs to integers. So since they are integers, we can write a proper solution set for it. So I can say solution, right? Let's write down all our individual integer values. We are going minus 4 is less than or equal to, so since it's equal to, minus 4 has to be included. After that we have minus 3, minus 2, minus 1, 0, 1, 2, 3. It's less than 4, 2 upon 3. So an integer value less than 4, 2 upon 3 is 4. That's our solution here, minus 4 to 4. Integer values from minus 4 to 4. Now we need to plot this on the number line. So first let's draw our number line. Here it is. And mark these values on the solution values on the number line. So we have minus 4. It's not very clear. See, minus 4. Right here, there you go. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. So these are all the integer values from minus 4 to 4 on the number line. This here is our final answer. So let's draw our rectangle around it to mark it as our final answer. That's the solution set and its representation on the number line.